Now that we've scattered some procedural clumping geometry, we can loop over our proxies and apply a unique clump value for each one of those distorted spheres. Now, in order to select each sphere individually, I'm going to use the connectivity information. So just drop in a connectivity SOP, and you can leave that attribute name at the default of class, but I'm going to switch it to primitive. Although this probably would work if you left it as point, as long as you compensate in the blast that we'll be setting up in a moment. And in order to get the total number of spheres, you could look it up from the scatter here, but a potentially safer way, especially if you were to generate these spheres with a couple different methods or a couple different passes and merge those together, then a safer way would be to use the max connectivity value to determine the number of times that we're going to run our loop. So drop in an attribute promote, and I'll call this max class, and we'll promote from prims to detail, and we'll select that class attribute. And we don't want to delete that class because we'll use that to isolate each sphere. So turn off delete original and turn on change new name, and we'll use max class as the new name. Now if you check the spreadsheet for that max class, we're seeing a value of 36 on those detail attributes, and that's not right. We've scattered more than 70 spheres here. So if you check the attribute promote type, you can see it's defaulting to a promotion method of average. So it's always important that you set this promote method correctly. And in this case, we want to set it to maximum, just to get that max class value. And then we can use this to determine how many times we want to run our for loop. However, this has a max class value of 72, but those class values start at 0, so we'll actually want to run this 73 times. Now let's drop in a for each number loop, which we haven't used previously in this class. And if you select the end, you can see you can specify a specific number of iterations for the loop to run. Now we'll use that max class info to set that number of iterations. So in that parameter, just type detail to do a detail attribute lookup, and we'll type in /max underscore class, and we want to look up the attribute called max underscore class. And for that final argument, you can just put 0. And then you can click on the iterations parameter name to toggle between our expression and the return value. So right now that's giving us 72, but we'll need to add 1 to that in order to get the real number of unique class values. Now we removed the manually defined clumps from our building when we set up the procedural scatter, but we'll want to include those sections for this loop that we're running, because at the end of this loop we want to have our entire building, or at least the sections that will have a valid clump value. This area we deleted down here won't be a problem because we don't want any clumping to happen in that area, but we just want to make sure we're running on all of the pieces that might get a clump, including those manual ones. So I've connected the for each begin to our blast non-clumped output to run it on all of this geometry here. Now in this loop, we'll want to isolate one of our distorted spheres at a time. So I'll drop in a blast node for that, and I'll call it isolate clump geo, and connect the max class to that. And on that isolate clump geo, just for now we'll isolate one sphere by typing in @class equals 0, and we'll flip this to delete non-selected. So it's only isolating just one sphere. And then if you connect that blast to the for each end and display that end node, it'll look like it's not doing anything, but this is actually running 73 times and accumulating a new copy of that sphere every time. It's not visually obvious, but if you middle mouse on that blast, you can see there are 500 polys there, and at the for each end, we have over 36,000 since it's accumulated that 73 times. Now if you take a look at the metadata node for our for each loop and check the spreadsheet for that, you can see there are some detail attributes with information about the running of the loop, and the one we're interested in is iteration. Since we're running this loop 73 times, that iteration value will vary between 0 and 72, and we can check the sphere class attribute against that to isolate one sphere at a time. Now on this blast, we could type in a detail expression here that references that metadata node. Sometimes it's a little bit more clean to use spare inputs instead. So on that blast node, go to that gear icon and then select add spare input. And you'll see it adds this extra parameter here, and you can drop any node in your scene into that spare parameter input. In our UI, you'll see it has this dotted line connecting them there, which is a nice little indicator of what is influencing this blast node, and that makes our expression writing a little bit easier. So in this class, we have to put this detail lookup in backticks in order for it to evaluate correctly. So in a backtick, type detail, and then instead of the path to the metadata, we can just type in -1 to reference that spare input, and we'll look up the attribute called iteration and just pass in a 0 for that final argument to the detail expression, and of course end with a backtick there. And now you can see that although this blast is just isolating one sphere at a time, if you look at your for each end, because we're running this loop and merging in a new sphere every time it runs, it's actually giving us all of our spheres in the output. Another helpful way to make sure that you have this detail lookup set correctly is to middle click on that group. You'll see this is evaluating to class equals 72, and that helps to make sure that you've set that all up right. If you ever want to add multiple spare inputs, that's fine. You can add as many as you want, and you can refer to those with increasingly negative values. So this is -1. If you add another, that'll be -2, and so on and so forth. Now the goal of this loop is of course not to output these spheres, but to accumulate some clumping data on our geometry input. Now because we want to accumulate a new clump value every time, we're going to want to rerun the loop on the same geometry while feeding back the output from the previous processing of the loop. So on that for each end, you can change this gather method from merge each iteration to feedback each iteration. So that means that whatever is output to the for each end, that will become the new input on the for each begin on the next iteration of that loop. In order for that feedback loop to work, you'll also need to change the for each begin node and change that method from fetch input to fetch feedback. Now this might have been a little bit easier if we were to, for example, set up our for each feedback loop instead with this preset here. We set up that for each number as our starting point, and that for each loop with feedback will automatically set the fetch feedback for you and that feedback each iteration. But all of these for each options here are essentially the same thing. They'll just be setting some different default values, so it's a little bit quicker to set up. And now instead of outputting the sphere to the for each end, let's group our input geometry. So on our group SOP, I'll call this clump and go through the same settings that we've done for geometry grouping so many times. Group types points, base group off, bounding regions on, and bounding object turned on. And we'll connect that group 1 to the for each begin, rename it to clumped, fix that group name there, and then we'll use this isolated distorted sphere to group our input geometry. Now it's hard to see if anything is being grouped right now. If you want to visualize this a bit better, we can drop in a blast and then delete that clumped group, and then flip that to non-selected and display it. So if we zoom in on that clump in our viewport, it looks like that was just hidden behind his arm there, and that one clump represents this sphere that we've isolated here. Now with this grouping setup, I'm going to use that to set a clump value on those proxy pieces. So I'll drop in a point wrangle and call this clump value, and then connect our group to that. And on this wrangle, we'll have this only run over our clumped group. So you can select that from the drop down or just type it in, since we have that annoying list of names in our group parameter there. And in this scene, I chose to have my clump values starting at 1. So we're going to retrieve the class value from the sphere and add 1 to it to set the clump value on the selected pieces. So I'll type in @clump equals a primitive lookup from input 1, which is going to be the isolate clump geo input, and we're looking up the class attribute from primitive number 0. The class value is the same on all the primitives in the distorted sphere, so looking up any primitive number is fine, and we can just be sure that a primitive numbered 0 exists. And then to have our numbering start at 1, I'll just put in 1 plus that detected class value. Now to check that that's working correctly, we can bring up the spreadsheet for that attribute wrangle, and it looks like we do have some pieces set to a clump value of 73, so that looks all good. But I don't want to overwrite any previously set clump values on every iteration of this loop. It's kind of down to personal preference how you handle these overlapping distorted spheres. Maybe you want it so that if one sphere overlaps another clump section later, that it overwrites that section, but I want to make sure that we never overwrite anything, especially because we're starting with some manual clump values already on this incoming geometry. If you check the spreadsheet of our input, we have some clump values of 10,001 and 10,002, so we want to make sure that those manual clump values are never overwritten by our procedurally scattered spheres. So in this clump value here, I'm just going to do a quick check on the existing value first, and we'll say if the clump value is equal to -1, which is that default value we set up, then we'll apply this new clump value. So if we've already set a clump value previously, there's no overwriting that'll happen. And then finally, we can connect that clump value to our for each end and display that. And I'll rename my for each loop to keep things nice and descriptive and fix this layout a little bit. And then we can check our output of the loop. So I'll drop in a blast and connect that to our for each end. And in the group, type @clump equals -1. And set that group type to points and display that. And this will show us all of our pieces that have a clump value, but it's also helpful to visualize this with color, especially if there are clumps adjacent to each other. It's hard to tell where one ends and the other begins. And point color generally doesn't work properly on these packed pieces, at least not currently. So I'm going to unpack this geometry, which isn't too bad because we're just working with the proxies here. The fracture will be a whole lot heavier to unpack. And on that transfer attributes parameter, I'll transfer that clump value. And then we could either use the color or visualize SOP to view some color feedback for each of those values. In this case, I'll use the visualize and connect the unpack to that. Then we'll set the color type to random from attribute, and the attribute will be clump. And then you can play around with that random seed if you want to. So now we have this nice color feedback and we can see exactly where those clumps are. And at this point, then you can go back and adjust your procedural scattered spheres if you want to adjust this at all. And of course, we can bypass the blast if we want to see that in context with the rest of the building. And now with these clump values set up, we can go ahead and apply this to our constraint geometry.